Hey everyone, welcome back to another Unity tutorial. It's been a while. I'm sorry, I don't have very much time to do these, but based on comments, it sounds like I should do them a little bit more often, so I'm going to make every attempt to do that. And I'd like to try to keep them a little bit shorter, because I realize some of them can get quite long, so I'm going to try to minimize the small talk, and we'll just get right into it. Alright, so this tutorial is about easing functions and just easing in general. And that may sound like a very foreign word, easing, but if you look online, you'll see there's quite a few examples of it used in different applications. And I'm going to talk about it as it applies to Unity and how you might use it in a game. So I'll first start out explaining where we would use it. And in games, typically easing functions are used more or less like any other application that isn't games, like some sort of user interface. If you have an iPhone on iOS, you'll see there's lots and lots of animation for UI elements, user interface elements, moving around and sliding and coming to a stop that make the user interface feel fluid and fun. Alright, so in order to demonstrate what easing functions are, I've got a scene set up here where I'm just animating a star object that's going to come out of the cylinder and go straight up and start pulsating. And the animation that I've got by default is a linear animation. The position is animating in a linear fashion. And so that looks like this. That is really boring if you look at it. You can see it just kind of comes right out of there. Here, I'll do it again. And it's just slow, and it just comes to a stop and then starts pulsating. That's pretty darn boring. Okay, so an easing function would be nice to use here to make it kind of come out more quickly and slow down faster, and or bounce or do something unique. And so that's where you would use an easing function, give it more life. Right, so there are lots of different types of easing functions that can be used. And I've got a list of them right here. Now, these all have different properties, and I'm going to demonstrate what each one of these does as I go through them. But for now, this is a good list, and I actually got this from just doing a search online, and I found a C# based library that included all these functions and all the math that's associated with them. Now, I don't know this math by heart. I would have a really hard time trying to reproduce this myself, and that's the great thing about game development, software development, is you don't have to invent everything yourself. You can refer to other people's hard work online, and as long as you give them credit, everybody seems to be happy. So I will show you where I got my set of functions from. The important thing here is leveraging that and using it in your own work, and knowing when and how to do that is also part of the fun and part of the challenge of game development. Right, so I showed you what this looks like when it is animated in a linear fashion, and we're going to change that and make it animated using one of the easing functions. So there's different aspects of this, and I don't really want to get into how you animate in Unity. There are tons of tutorials on that, and I'm not really trying to do any better than those. But I will say that the way that I implemented this might be interesting in and of itself. So if you pay attention to what I'm about to show, it might help you in some other aspect of your game development with Unity. Okay, so let's try and see what happens when we use an easing function on this little star here. So I've created my own script, and I'll show the source code for this in a bit, and I'll try to find a place to put it online to make it available for you guys to use as you'd like. So I'll explain this towards the end, but right now, don't worry about what this is or how it works. Just bear with me as I kind of go through these functions, and you can get an idea of what these functions look like in action. So right now we have it set to linear, I'm going to change it to quadratic. And I'm going to leave everything else the way it is. And when I click this button, you'll see the animation changes. Now I've got a more of a smooth looking star coming up. Doesn't quite look great, but it's a good start. Let's see what one of these other ones does. So cubic, slightly different, but kind of more the same. And as I go through the next couple, they'll be similar. You'll see they kind of go faster and start out faster and end slower, and progressively faster and slower as you go through these. There isn't much difference between these, so as you do this, you just kind of use what looks right to you. Then there's some other ones that get a little bit more interesting. So this sinusoidal one is more like a sine wave, but you can see it's just kind of more like slow start, regular linear in the middle, and then a slow end. Again, maybe not quite what you're looking for, but that might be appropriate for some other kind of motion that you're going after. Exponential, these all seem very similar. So now these ones here start to get a little bit more interesting. The back animation kind of goes up and then back down a little bit, like that. I'll do it again. So it's kind of like, almost like you're hanging a picture on a wall. That might be something you think is good for your application. The next two are my favorites. So I use bounce quite a bit. I really enjoy seeing this animation used, and you'll see this one used a lot on, again, iOS apps. And that looks like this. So it kind of comes out fast, hits the top, bounces back down a couple times, and kind of comes to a rest. So I kind of like that. In fact, that's the one I've been using in my game. But Elastic's kind of cool too. It's kind of like there's a rubber band tied to the star, and as it slows down, it kind of comes to a stop. Almost like it's on a rubber band. So you can see that. But you can see that looks very smooth, very realistic, and gives life to that animation. You compare that to the linear, and there's no comparison. It's completely different. Circular is the only other one that I have on my list, and it's also very similar to the other ones. So in general, the ones I use are bounce and elastic, sometimes back. And if I'm just looking for sort of a slow start and a slow end, I'll just pick one of these other ones, and whichever one kind of looks the best to me. And again, they're all very similar. It can get a little different when you have a longer animation or a different kind of object that's being animated. You just have to play around with them, and there's quite a number of possibilities, especially when you adjust the number of keyframes or how long the animation is. And these are all based on the script that I've written. So let me describe what I have here for my easing helper script. Now, I wrote this in C#, and it's basically a script that generates the easing curves for a specific property on a game object. So the way this works is you give it the animation clip that you are wanting it to write to, and the property name that you want to animate, and it can only animate one property right now. In my case, I only need to animate the Y position of something, so that's why I specify that here. But you could easily adapt it to multiple properties. But for this purpose, I just needed one, so I'm just having one property. This could have been an array with additional properties. There's some menus, drop-down menus for the type of curve and the mode, and this lets you specify how long the animation is in keyframes, which is not the same as how long the animation is time-wise. The reason I have it this way is just because I wanted to control how many different keyframes it generated, because I think the more keyframes you have, the smoother it'll be, but it might be more than you need. And if you have too many keyframes, then it can eat up more memory or something like that. And there's really no need for a large number of keyframes anyway. So if you're not familiar with animation in Unity, you probably want to become familiar before you attempt to understand all of this. I'm not going to explain it in detail, so I'm assuming you already have some knowledge of how animations work in Unity already. Okay, and so then you can specify the length of the animation in terms of time, and this is in seconds. And then I have an adjustment here for the maximum amount of time you want your animation to last, regardless of the number of keyframes. So it's a little bit complicated. These are things that I kind of tweaked over time because I wanted to have more control over my over my animation. So if you, sorry, let me switch to the correct animation. So this is what the animation looks like in terms of the keyframes. So you can see it's 1.5 seconds. This is in seconds. This is in this is 1 minute 20 seconds, 1 minute 30. So you can see this is a minute and a half, and it generated this many keyframes, which should be 20. And so when anytime I generate the curve, it'll generate the keyframes. And it's quirky, but you have to collapse and expand this to refresh for whatever reason. There's probably a way to do it programmatically. I just hadn't found it yet. And I also have a scaler here, which is basically it allows you to scale the resulting animated value by a certain amount. The resulting animated value is going to be between 0 and 1. So both the input and the output to the animation function, the easing function, are values between 0 and 1. And this scaler multiplies the output by that much. So if you want, in other words, if you want the position to end up at position like 75 as your final position, you have to multiply by 75 because it's only going to go from 0 to 1. And if this sounds a little bit confusing or unfamiliar, you might want to check out one of my earlier videos where I talk about scaling vectors. Position is a vector, so you can think about it that way. Okay, so another interesting way to look at this is to, instead of using the dope sheet, is to use the curves. And if we look at, if I just select the Y position, because that's the only property I'm animating, the other ones come along in the animation regardless of whether I want them animated or not, but their values are always going to stay at 0, so I'm not worried about that too much. But if you look at the curve, you can really see what these curves look like in graphic form, and this is super nice to be able to get an understanding of what your value is going to do. So you can easily see that this Y value stays at 0 for a while, kind of starts to slowly go up and up and up until it finally finishes at 1. And since again the result is always going to be between 0 and 1. And if this isn't good enough for you, you can always scale it, you can add, subtract to it, you can always modify this value after the fact. The key is that it converts this value, this x value, which is time, to a y value using a function. That's basic math. You've probably done this in school, like when you were 7 years old, 8 years old, whatever. But here it is in practice. And so as I change these functions, you can see what these graphs look like. So again, you have to expand, collapse. It's a pain. So linear, obviously, nice line. Some of these other curves are pretty interesting to look at. So this one looks like this. So it actually goes below 0 for a bit and then back up. Finally finishes at 1. And you can see the animation up there. And I have this set to in right now, so it's doing it at the beginning. Like I said earlier, I prefer the out version of the mode of the curve because that makes more sense for a user interface element. So here it is. And if I play it, Yeah, you can look at that. Let me turn this on. All right. Get a better view. Yeah, so that's your back animation, and that's what it looks like in the curve. And just for good measure, let's do bounce and see what that one looks like. Collapse. Okay, and that's pretty cool looking curve. And that was generated through math, just with different equations and functions to generate these values. Now you could easily do this by hand, but the reason I do it this way is because these functions already exist and they're already, like I said, kind of standardized in the user interface space as, you know, common user interface or easing animation functions. So no reason why you need to go reinvent the wheel, but you're obviously able to hand animate. You can even adjust these after the fact if you want. If you don't like the way it looks, you can obviously do this. But, you know, for my purposes, I just kind of left it the way it is. But yeah, this obviously is, you know, probably not something you're going to want it to do. So one question you might ask is, why not just have pre-canned animation clips that are called animate position Y using easing bounce out? Well, you could certainly do that and then just apply it to the Y location of a specific user interface element, but that's not as flexible as being able to generate it as needed and specify a parameter at that time. There's nothing wrong with generating the animation and then saving that clip and then using that. In fact, that might be what I would end up doing at the end of all of this process. This is just a script to help you get there. So this isn't necessarily expected to be used at runtime. I mean, after all, I am creating a clip anyway and saving that clip. Once I'm done tweaking my animation, I can remove this script and I have my animation baked and I don't really need to generate curves anymore. And if I ever do, I can always add the script back in. So think of this not as a runtime thing component, but more like a scripting time or a creation time script. And that's its intended purpose. And that's what's great about Unity is the editor is the tool set as well. So any tools that you need to create content, create assets, you can use the editor itself to build your tools that way. And so this is my animation generation tool. So let's take a quick look at my easing helper script here. And as I alluded to before, I'm using easing functions from a library that I found online, or a class that I found online. This link, which you can follow yourselves if you want to copy the functions the way I did. I have that in a different file here. This file is pretty much verbatim compared to what I found online, so you don't really need to modify this in any way, and I didn't. But if we take a quick look through this, you'll see there's a lot of math and there's a lot of magic constants and functions that someone obviously took a lot of time to figure out and condense into what we have here, and so we can thank them for that. But otherwise, all I did was take this and leverage it for my purposes. So this script starts with, like I said, takes an animation clip. So that's the animation we're going to be modifying, and the property name that we are going to be animating. Enums for the curve type and curve mode. So curve type, you've seen this before, and the curve mode, in, out, and in, out. The number of keyframes, and as I said earlier, these are the other parameters, the time, the maximum time, and an optional scaler that you can use. To make things easier for me, I just created an array of functions, and I like this format in C# just because it makes it easier for me to understand how things are working. And there's a lot of setup, so obviously a lot of typing, copy paste for this. But essentially, I've got a two-dimensional array and mapping the curve type and the curve mode to a function. So this is pretty straightforward. And once we have this set up, we can then move on to the main function. So taking a look at my main generate curve function, the first thing it does is it figures out which function we want to use for this easing animation. Then we're dividing up the total amount of time by the number of keyframes and applying the easing function for each of those. And so I have this here, I said before about having a maximum amount of time. If our time goes beyond that, it just cuts off, even if we haven't reached the number of keyframes that we are looking for. So that wraps up another Unity tutorial. I hope this one was interesting for at least some of you, and I'll make every effort to try to make more in the future. Thanks for watching.